Hi there, folks. Today we're looking at measures of central tendency and dispersion. And the measures of central tendency, these are the ones that we've done for about 1,000,000 years now. Mean, median, and mode, okay? Remember, the mean is the average. It's when we add them all up and then divide by how many we have. The median is the middle value. That's when we have to put them all in order and then find the one in the middle. And then the mode is the one that appears the most often, okay? So these are used for kind of summarizing data when we talk about measures of central tendency. So again, mean, add them all together and divide by how many we have. It's the average. The median I think to me is the most tedious of all of these because we have to rearrange them, put them in order first, and then start working our way to the value that's in the middle. And remember, if there's a tie for what's in the middle, you have to take the average of those middle two. So you take the mean of those two values. So if there's a tie for the middle, so if there's a tie, we find the average of those two, or find the mean, okay? So just remember that that little nugget. For the mode is an interesting one also because we have to remember that there can be more than one mode. So if there's a tie, we have more than one mode. But in order to be eligible for the mode, it has to at least repeat more than once. So if there's only one of every value, then there is no mode. So that's like an extra little piece attached to that. So if there's no repeats, then there's no mode. Okay, so there's a couple little stipulations that we have to worry about with some of these. Again, median, if there's a tie for the middle, we find the average, and that's our median. The mode, if there's no repeats, then there is no mode. But if there's a tie for the one that repeats the most, then there's more than one mode, okay? And in terms of which of these we tend to use when summarizing data, the mean is like the default in terms of being the best, okay? So I'm going to say default best. So if it says, what's the best measure of central tendency, we default to the mean, all right? The time that we won't use the mean, the time that the median will be the best, this one is the best when there is an outlier. And we're about to talk about those in a moment. Okay? And then the mode, we almost never pick the mode as the one that's the best, unless for some reason almost all of our values are the same. But in that scenario, the median would work out as the middle value anyway, all right? So the mean is by default the best value for measure of central tendency, the best measure, but the median gets used when we have an outlier, okay? And if you recall, outliers are these values that are much greater than the rest of the data values or much smaller than the rest of the data values. They're so far to one extreme that they almost don't count and shouldn't count, all right? They're way too big or way too small compared to everything else. They're kind of a special case that happened within whatever scenario we're discussing, okay? For example, if I look at these guys, I want to find the mean, median, and mode. I have 8 bowlers and their scores here. And the first thing I might do, like if we're just finding the mean, I would just start adding these together and dividing by how many I have, all right? But since I know I need to do mean, median, and mode, the first thing I like to do is get organized by writing these down in order. So I've got a 104 is the smallest, and it looks like I have another one of those and another one of those. And an easy way to stay organized is just put little marks next to each of these as you get them. See, I'm putting little check marks there, put little dots, or do whatever you need to do to kind of mark. What I wouldn't do is I wouldn't cross them out in case for some reason I need to still read that value. So it looks like I get a 109 next. And then after the 109, looks like the 113. And then the 117. And then the 136. And then that 189. Okay, but make sure you're just keeping a tally of, okay, what have I written down so far? And another nice little check that you can do at the end is you can just count up how many data values you have written down just to make sure it at least matches the total number of data values that you had, all right? And so now from here, I want to find the mean, median, and mode. So the mean, I'll find that one first. You'll also see the mean abbreviated this way as an X with a little bar over it. That also indicates the mean. And in order to do the mean, I'm just going to pull up my calculator here, and I start adding these up. So 104. And most of the work that we do here is done on the calculator. Okay, so that's the addition, and now I have to divide that by how many I have, which was 8. So I get a 122. And notice how I plugged that into the calculator. If you want to try to punch it all in one shot, that stuff divided by the 8, you have to put all that addition in parentheses, or it's only going to divide the last value, okay? So I like to punch in the addition, hit enter, and then divide it by the 8, all right? So that's the mean. The median we start marking off from each end. And then once again, I am not going to cross these out. Maybe I'll underline them, put little dots. So there's the two ends. So it's like I'm crossing those out. But again, I don't cross them out just because I want to still be able to read them. And then I take another one off of each end. And when it's all said and done, I get down to these two values kind of tied for the middle. So these guys are tied for the middle. So what I do is I find the average of those two. So I do the 109 plus the 113 and divide by 2. And here's the thing, you could get away with not actually doing this work. The average of just two values is whatever's halfway in between. And you might be able to look at 109 and 113 and say, okay, the number that's halfway in between those two is a 111. Well, that's what the calculator is about to give me. If I do the 109 plus the 113, again, I hit enter and then divided by the 2, I get 111. So that's my median. So I've got the mean, I've got the median. The last thing I need to do is find the mode. It looks like I have a 104 that repeats 3 times. No other value comes close. So the mode this time is the 104 because that value repeats the most often. And that's it. So mean, median, and mode. All right. The follow-up question to this is which measure of central tendency is the best for this data set? And again, by default, we typically go to the mean unless there's an outlier. So I have to look at this data and say, okay, are any of these data values much bigger or much smaller than all the rest? And hopefully you look at this and say, well, yeah, this guy right here, not even close, right? That 189 is much bigger than the rest, okay? So when I think about that 189, I would consider that an outlier, which means the best measure for central tendency this time is the median. And it's a median because an outlier exists, all right? If you were to find the average, if you were to find the mean without that 189, it'd be a lot closer to the 111. That's what the median does. Because when you think about how we found the median, we cut off the values starting on the outside, so we cut off those extreme values, okay? So we're going to go with the median this time because there's an outlier. Okay. All right, so in this example, it says your grades on 3 exams are 80, 93, and 91. What grade do you need on the next exam to have an average of 90 on the 4 exams? And so basically the situation is this. We're trying to find the mean or the average here, and we have 4 exams total that we're talking about. We have the 80, the 93, the 91, and then one that's yet to be determined, so I'm going to call it X. And those are the 4 exams that I want to find the average of. So I have to kind of take the definition of the mean literally here and say, okay, the average is when I add all these together, even though one of them I don't know, and then divide by how many I have, even though, again, one of them I don't know, there's still 4 exams here. And when that's all said and done, I want the average to equal a 90%. And so now from here, it's just a matter of simplifying this thing. So it looks like I get a 264 plus x over 4 equals the 90. And now this is just a linear equation that I'm going to solve, so I'm not real happy with that division sign. But if I was solving this linear equation, remember it's implied that there's parentheses around this, so I have to undo the division first, so I multiply each side by 4. You could also put that 90 over 1 and cross multiply, but here the 4's cancel, so I'm left with the 264 plus x, and that equals a 360. And now I'm going to subtract that 264 from each side. So I find out that x equals, looks like a 96 over here. So in other words, in order to get the correct average, I need a 96% on that final test, on that fourth exam, all right? And you can very easily check this thing by plugging it back in. So if we want to, we can check it on a calculator. Let's find the average of those exams. I do an 80 plus 93 plus 91 plus the 96, and I divide by how many I have, which is the 4, and it does indeed give me that 90%. So again, we're just kind of working through this thing with the variable in it. It results in a linear equation, okay? If we talk about measures of dispersion, the only one we're going to look at here is the range. And the range is the difference between the highest and lowest data values. We're essentially looking at how many data values are covered, all right? And so if we look at these, this last example here, it says the closing price of 2 stocks for the first 5 days in February are shown. What is the range and mean of each data set? So I'm going to start by finding the mean. And again, you can just say mean, or if you want to abbreviate it with the X with the bar over it, that would also be fine. So I'm just going to add them all up and divide by how many I have. I'm going to do this right on the calculator. And it looks like I have 5 data values. So that one has an average of 32, so that's the mean. Over here, doing the same thing with the next one, while I have my calculator pulled up. So I've got the 34 plus the 28, 31. And again, divide by how many I have, which is the 5. So I get an average also of 32. And so each of these has the same average, but now I want to compare the range of the two as well. So let's look at the range of each. The range is just the biggest data value minus the smallest data value. And so in this example, the biggest data value is the 47. And it looks like the smallest data value is the 25. So when I do the 47 minus the 25, it gives me a 22. The next one, again, if I'm looking at the range, it's the biggest data value minus the smallest data value. So in this one, it looks like the biggest data value is the 36, and the smallest data value is the 28. And if I subtract those, I get a range of 8. All right. And see, this is very telling for us, because if I'm looking at this, especially in terms of something like a stock, the average of each of these is the same, but the range of the first one is a lot higher than the second one. Okay. And what that means is that the second, stock B, is a little bit more consistent when it's all said and done. All right. So if we're talking about something like stocks that we're planning on investing in, that first stock varies a lot more. It's up and down. So the extremes of how low and how high it goes are a lot greater than the second one. So the second one is maybe a safer type of stock in terms of its consistency. All right. So they each have the same average, but stock A is a lot less consistent than stock B. All right. And that's kind of what the range tells us. It's telling us how far spread out this stuff is in terms of the smallest value and the biggest value. Okay.